Okay, check, audio, check. All right. Cool, so I've been working on this project, HTML, CSS renderer. Gotta mess with my audio for 1 second. There we go. Okay. So I've got this HTML, CSS renderer project. It is a sort of like a mini browser, and the plan is to be able to render HTML, CSS pages minimally with a tiny amount of Zig code, basically. So I have this really cool little web page I made with it that lets you see both this renderer and the native renderer side by side. So I can Zig build WASM. It'll build this WASM page, and then you can see it side by side. So left side's the custom renderer, just all in WASM, and the right side's just an iframe. So if I take like a little web page here, copy and paste it, and we can see the native renderer here on the right and then my renderer here on the left. So anyway, that's a fun project that I've been working on a little bit for a while. But today, what I wanted to look into was creating a small, like, little application, an image viewer. So I've got, like, I think I have all the pieces in various places. I've got a way to display images through X11 via my ZigX library. And I also have, I think there's a Zig image repository that I could use to parse like various image formats. So I thought like making a little like image viewer application in Zig might be a fun little project that I could do, you know, pretty quickly. So I thought that might be a fun thing to stream. So with that, let me see if I can change the stream topic here. I've got to remember how to use Twitch here. It's like, see, maybe it's in like the creator dashboard thingy. Manage stream. Okay, yeah, this looks promising. It's taking me through a tour. Okay. Edit stream info. There we go. Writing an image viewer in Zig. Cool. So I've got my little create a new repository page up here on GitHub. Image viewer seems like a good enough name. Oh, you know what I forgot to do was get the chat window up. Oh my gosh, what is Christoph's tool called? Oh, Bork. We've got to get Bork up. Come on. Let's see if I still have it in my path. Bork. Okay, yeah, there it is. Bork start. Uh-oh. Segmentation fault. That's not good. Christoph, Loris. No. Okay. There's got to be another way to get the Twitch chat up. Let's see. Stream chat. Okay, so we could do it this way. It's a little hacky, but it'll have to do for now. Okay, I think maybe I'll move my image over there. Yeah, sure, why not? It's good enough, right? Ah, come on, how do I make this bigger? Maybe I can pop this out. Oh, pop out chat, yes. Okay. There we go. Move me back over there. Very nice. Okay, let's create this GitHub repo. So image viewer experiment written in Zig public. And oh, I can make a license right away. Sure, MIT, I guess. I'll just add my own license, it's fine. Create. Set up a new instance of Emacs here. Hopefully that font's a good size. Image viewer. Okay, image viewer. Image viewer experiment Zig. I'm not going to worry about a license yet. Zig init exe, is that what it is? Main.zig, build.zig. Let's get rid of all the cruft that's in there. Install, yep, we want that. Do we want run? Yeah, I guess we can keep run. We don't need the tests, we don't need the test step. Okay, Zig build. Oh, I got to change the source to there. Should run. Yep, okay, I think it's working. Cool. Run, oh, it's got like, they've enhanced it a little bit. Okay, are we gonna, I don't think we'll need any of this. Yeah, they've added some things to the default main file, which is pretty cool. I like it. I like to see it. Cool. All right, so first thing that we're going to need is we'll get it running, I think, on X11. I'm on Ubuntu right now. We can get it running on there pretty easily, I think. So let's go ahead and add my ZigX library as a build dependency. So in order to do that, I'm going to copy my git repo step so that it will automatically download it as a dependency. Build repos, git repo step. Okay, let's go ahead and import that in our build file. And then we'll add the repo. I think it's const. Let's call this ZigX repo equals git repo step. ZigX. Let's go branch equals null. Let's say SHA equals something. Let's go get that SHA. Close that. Okay. I just started adding xrender extension, I guess. So, and then I have this fetch enabled. I'm just going to always set it to true, so you don't have to like say that you want to fetch. So we've got our repo configured. Let's go ahead and add it as a dependency. And then we need to add it, let's add it as a package. I think I usually call it just X, the X package. So b.pathjoin Let me turn off these messages here over here. Okay. b.build. No, I need to do zigx repo.path and then x.zig. Okay. So as long as I didn't make a mistake, I should be able to it should automatically download the repo. Let's see if it works. Okay, no member depend on. I forgot the .step here. Oh, looks like that was the only mistake. Cool. Okay, so that automatically downloads zigx into this dep directory. So we could start with the example there. So there's a small example that just creates a window that says hello. So let's just copy that. Start with that. Okay, we've got a file called common.zig. I'm just going to copy that into this repo for now. And I need to update a couple of references in here. Contiguous read buffer. And common also needs to be updated. Okay, what's next here? Oh, what's with all these errors? Oh, I just saw a PR with this field type change in it. So this would be a change to the Zig compiler, a recent change. I'm trying to think what we should do here. I could just change to an older version for now and not worry about it. What version are we on now? 9.26, so is there like a 9? What if we just sort these here? Okay, so we got 9.26. That's this one here. So you don't want any of the .10 ones. So let's just look for 11. Okay, so it looks like 7.15 is the last one I had. So let's switch to that version. Go ahead and build. Okay, looks like we're building now, so I should be able to run it as well. And there we go. So there's our window for our image viewer. Let's go ahead and clean this up a little bit, maybe. We've got some logging around the X messages. I have some comments. What does this do? Graphics context. Okay, I'm not going to worry about this code too much, but the main thing that we're going to want to be looking at is this render function. So that render function is where we send our X11 messages to draw our image for our image viewer. And I do have already another project where I can capture a webcam and draw it to the X server. Maybe I should get that, see if that runs really quick. What did I call that? Got image viewer, media stream. Video server. Okay, so this one, like I could take another, I don't know, let's take another one of my webcams to show preview. Okay, so this is using that same zigx library, and I can just go in here and look at which commands it's sending over to the X server so that we can draw an image. And let's get an image first. Actually, we could take this image. It's a PPM file, so PPM is a really simple image format. Actually, we could generate an image too. Like maybe that should be part of the testing, is to generate a small image and display it. Genimage.zig. See, how do you generate a ppm image? I have one, image renderer, P6. Okay, right here. Okay, so this is basically a ppm image. You start with like P6, you print out the width, the height, the maximum pixel value, and then your image data. So let's write this small program to do that. We could just write it to standard out for now. Writer. Okay, and then print. So make it, I don't know, 400 by 300, I guess. And then 4. Okay, so we've got a loop, and then we'll just do, let's do a buffered writer here. So const bw, or is it supposed to be var? Var bw equals standard IO, buffered writer. Let's just call this standard out maybe. And at the end, we'll want to flush it, bw.flush, try. And let's make this into bw.writer, bw.writer.print. Is that what we want? Or write all. So you write the pixel data here. So I don't know what we want our pixels to look at. Maybe let's just do a simple like gradient or something. 3 U8s. So we can just take, I don't know, like the row. I don't know, let's take this to a U32 Y plus X. Gray, I don't know, gray. And then we'll AND that together with FF to get the lower 8 bits. So gray, gray, gray. We'll just make it grayscale for now. Pixel. Okay. It needs a semicolon somewhere. This can actually be const. Okay, what do I? 19. Try. That should be writer. Okay, so we wrote the image to standard out. Let's write it to image.ppm. And how can we view it now? What's my image editor on Ubuntu? Let's use the File Explorer to just double click it. Okay, so that's our image we just generated. Should make it like cooler though. What could we do to make this cooler? Tweak the algorithm a little bit. Like we could give it, we could make it a, what is that, RG, no B, what's that going to be? Red and green without blue. Orange? Yellow. But let's do like, this will be like our red channel or something, like red. We gotta do something like different for ref. No, I wanted red. That's weird. And refresh. What's going on here? I need to reopen it. Oh, weird. Okay. What should we do with the blue? Like, maybe we swap. We could offset it, or we could like not do the row. That could be one thing. So we could do like this. Just have it be X. Yeah, I think we still need that. Okay, that's interesting. Reminds me of like a fruit roll up. Let's add some blue in there. Maybe that we just do the row with that one. Whoa. Blue. Oh, that's kind of cool. Pretty interesting to look at. Maybe we make it 256 by 256, so we don't get that weird repeating pattern. Okay, that's cool. So we basically get like, it's not the full like range of colors. Is there a way to get the full range of colors actually? No, I don't think there is, because I think we'd only, if we just set the red to 0, then this is the full range of colors if you just have green and blue. And to get with red, I think you'd need like 6 more of these or something. No, 256 more of these. So that'd actually be a really big image to show like all the colors in a pixel perfect. Like have every pixel be a unique color. I think that's right anyway. Not sure, but. That's kind of a cool image though. I kind of want it to be, see, we're like almost black here. Almost white here. Huh. That's probably good for now. Okay, so the goal is to get this image in our hello world example. So instead of this hello, we want this image. You want to be able to give it an image file and then have it display. So let's look at that other project I had, media stream, and let's see how that one worked. So it should have like, here it goes, send put image. That looks familiar. Let's just yoink that one out of there. Send put image. And let's see how it called it. Send image. Okay. So send image called send put image. Okay, so send put image I think is a single command, and send image, we'll call send put image as many times as it needs to. Because send put image, I think, has a maximum size that you can send. So let's just copy both of those over. And let's go ahead and make an image and send it over. Maybe we'll just copy our gen image for a second here. Our gen image. Or do we need to really? Like let's just make an image here. So width and height 256 is fine. Let's get a buffer going. Let's see, how does this work? Got a width and a height and a stride. Okay. So call this image maybe, and we'll go width times height times 3 for 3 bytes per pixel. Is that right? Let's make that a variable. And let's do stride equals width times BPP. So we'll go height times stride. And we just want to put something in it for now. So let's maybe copy our loop, something like this. And we'll just say, need to get our offset. Maybe we'll just like save the offset. So image offset plus 0 equals, I don't know. Yeah, we'll just copy our red, green, blue that we're already doing here. And then offset plus equals 3. Okay, so we've got our image, and then I think we just call send image. Sock max request length. That is something I don't think we have. Max request length. Where do we get that? So that comes from the connection setup. So after we set up the connection here, we'll get the max request length. Okay. So we'll just pass it in, even though it doesn't exist yet. Sock max request len drawable ID. I think that's just a variable I have. GC ID, so I think FG foreground. X location will pass 0. Or let's just pass 10. Y location will pass 10. Width is going to be width. Height is going to be height. Stride is going to be stride. And data is going to be image. Okay, so we call that. That should send an image over. After we fix all the errors. Oh yeah. I can't use X because that's the name of the module. Okay, now max request length does not exist. Let's go ahead and add that. And that should probably go somewhere like here. Max request len. What is that? U18. I think that size is based off of the X11 protocol, how many bits it actually uses for that. Okay. os.sockeT does not exist, probably because I need to add std. How many of those am I going to have? Probably not that many. No built-in. .388. Oh, this is interesting. So, yeah, I kind of remember this now. This put image command actually uses a write vcall to pass in like a IO vector. So the header part of the message is in one place and then the data is in another place. So it's able to compose the message from two places that are in different locations in memory. Kind of cool. Cool little trick. Won't work on every OS though, as far as I know. I don't know, maybe, I think Windows might have something similar. I don't know. Okay, so now we've got to actually pass in our max request len. Okay, and 286. What's wrong here? Comp time int. That's just that. Okay, and then image needs to be ampersanded. Okay, so we ran and then we crashed. Why did we crash? Let's do this instead. Let's do zig build and zig out bin image viewer. Oh, it doesn't tell us why we crashed. Did we crash? This couldn't be like one of those, what's it called? That Linux signal that causes your program to exit. Sig pipe. It's not a sig pipe, is it? Exited with code 1. Oh, we got an error. Okay. So what is the error? It is 102760450 is our error. It does say there's an error with our put image command. Not 100% sure what this, oh, it's length. So maybe we sent an image that was too big. So it's saying the maximum request length is this many bytes. How many bytes is our send put image? Let's see here. Maybe we'll just log it for a second. Message len is, and that's going to be message.len plus data.len. Let's try that. See what our length is. It's 196632. Yes, it's smaller than this, but maybe like the server's not well behaving and it's not giving us like the right size. Let's just like set it to something lower. I don't know, what's a good length? 50,000? So it should split up the image. Unused function parameter. Still length. Ooh, that's interesting. I don't know if it actually split up the image. Did it? Message length is it did split up the image. Okay, so to 49,000. Okay. What does that? Could actually, maybe it'd be helpful to look at the zig specific, or the not zig, the X specification, and see what that length. It could be like a length mismatch or something. 246 matches. So I think if you go to like put image, errors, drawable, G context match value. Does it say anything about length? Errors, page 4. Whoa. I feel like I should be somewhere around page 4. Here we go, error. Length. The length of the request is shorter or longer than the required to minimally contain the arguments. Okay. So I think my image, my put image is like malformed somehow. So we could actually use something like xtrust to see what it thinks of my commands. Let's try like decreasing it to like even smaller. Like what's the minimum length that this could be? Each line is, let's see, it's 255. So 255 times 3, I don't know, like would one line be like fit in 1,000? What's it going to do with that? Okay, so 792 sent a whole bunch of, I think probably, yeah, these would be single rows of images. So let's see what xtrust thinks of that. Ooh, bad length. Packet ends prematurely. Okay. So yeah, our image, there's something wrong with our image here. We could be sending it like the wrong stride or something. Oh, you know what? I think this is supposed to be 4 bytes per pixel. Yeah, and I'd actually need to do this as well. 3 plus equals 4. Okay, let's try that. Line is too long. Okay, yeah, so we need to increase our max a little bit. There we go. Okay. So we're sending over a randomly generated image. We want to ultimately be sending over an image that we read from a file. But we can send over images. So let's change this back to max request length. Okay. So for now, we're sending over like a 4 bytes per pixel image. X11, the way that it works is it has depths. I print them all out here. When you negotiate the connection, it sends all the supported depths. And I think somewhere it says like what depth it's currently set at. Yeah, root depth is, so it's saying is 24. So that means, I believe it means it's this entry here. So it's telling you it has 32 bits per pixel, the scan pad. So this just happens to be what format this X server is currently on, but the real program should ultimately either negotiate a depth that we can support, or at least query the depth that the server is using and use that. But for now, we're just going to assume that this is the depth that we're using. And then we can add that later. So this image viewer isn't supposed to just run on Linux, so this would just be the X11 backend. So maybe we should put like some of this X11 specific stuff in its own file, and we can maybe do some OS detection or X versus Wayland detection. It'd be nice to add Wayland support as well. So let's see what the best way to do that is. Probably put all this stuff in a file called X11. Or maybe that's not a good file. Maybe like X11 backend. It's probably a little better. So let's go ahead and put all this stuff in that file there. X11 backend. Let's just put anything that references X over there. Let's move common into X11 common. Okay. And then if we build, we should just, as soon as we're able to build again, we should have moved everything over. So I think we're going to need to move maybe we do like X11 backend. So we could do like a const X11 backend equals dot, I don't know, what do we call this? State. State. And this will have this connection data, which let's go look what that is. Connect result. So we'll call this con. We'll make an init, a dinit. We'll shut down the socket on dinit, and then the init will call this. Okay. Let's see what that does. Okay, use of undeclared connection con. And the init probably should also do this screen stuff. Or maybe, yeah, init. So init would like make a connection to the X server. That's fine for now. We'll just do that. Okay, so that means we're gonna have this be able to return an error. And then probably don't need this anymore. Dot screen equals screen. So what is a screen? It is the return value of get first screen pointer. Get first screen pointer is, okay, it's a screen, so x screen, x dot screen. I don't know what a screen is. What is a screen? I wrote this too long ago. Okay, so a screen is a struct. Probably this should be a, I'm guessing it should be a reference. Yeah, get first screen pointer, okay. Okay, so back to our main file now. So our init makes a connection. Max request length is set there. I'm just wondering if we should be storing this at all. I mean, we can store it. Sure, why not? Was it a U18? Yeah. Dot. Okay. And we we could still print it here. It's fine. Oh, I just saw Matuba said something. Hey, what's up? We are making an image viewer right now in Zig. So it's a small little like application, taking a little sidetrack from my HTML CSS renderer, which is my main project I'm working on right now. So I thought this would be like a fun little project I could do like pretty quickly. Something fun to like stream. So yeah. Okay, so now it's the rest of the setup. This should probably all just be in the setup, honestly, for X11. Just go ahead and copy the rest of this into the setup. And then the loop will be the will be another like part of the interface, I think. Okay, so yeah, we can print that here. Actually, we're not really using it here, so we'll just not print it. Let's format all this. Okay. All right, so set up our connection. We do some connection negotiation, print some data about the connection. Maybe we'll still print this over here, I don't know. Then we set up a window, we do a create window, register for certain events. We set up some graphics contexts. Probably we'd only need one graphics context. Maybe we'll make a comment to do. Probably only need one graphics context. We get some font information. We'll probably want to render text at some point, so that's fine. We set up a double buffer for receiving into. And then we will return, and then we map the window, so we'll return all of our state. Okay. And then we'll need to, for now, we'll just do like a pub fn loop. Or what's that called? A window loop or a window? Yeah, is that right? Window loop? What are they called on Windows? Okay, let's see if that works. X11 state.window loop. Okay, so all this render stuff I think moves into the other file now. Yeah, it should all go over there now. Okay. So now we need some sort of an allocator somewhere. You could pass in an allocator maybe. Should we pass in an allocator? Let's avoid that for a second. Let's make our own allocator for now. No, let's pass one in. And then when we dinit, we will try to remember to unallocate. So the connection takes an allocator. So I'm guessing the connection can unallocate somehow. So we're allocating this connect setup. Does this have a deinitialization? So there's a buff. Okay, so X has a connect setup. This does have a D in it, okay. So connect setup. We probably need to call dinit on that. Is that right? Yes. Okay. So there's a setup field in connect results. So we need to do allocator dot con dot setup dot dinit allocator self dot allocator. Okay, I think that's right. And then we'll pass in our arena allocator. Okay. I have not imported standard yet in this file. Okay. Okay, so now we need the window width and height. So that maybe that's a good thing to take as a parameter for the init function, maybe. Window, maybe window size. Nah, let's go window width 32. Window height. Okay. Let's pass that in. I doubt that they're actually U32, so we could probably just cast them, but 27, it doesn't use font dims for some reason. It's used right here, though. That's odd. Oh, it's because it's not used until the window loop, so we need to save it. Okay, 160. $161. Okay, there's no buff. Probably need to add that as a field, I'm guessing. Yeah, contiguous read buffer. All right, so let's add that as a field. Okay, probably needs to be self.buff now. We need to pass self in. State. 71. 174. 179. 182. 186. 225. This is a pretty big function. Let's go ahead and split it. 228. Window ID. Okay, so So how the window IDs work is you actually allocate them yourself, and then you send those IDs over to the X server. So we actually don't need to save these IDs. We can actually save a base ID, which is here. So resource ID base, let's save that. And what is that? What is the type of resource ID? Let's go look it up. Resource ID base is a U32. And then let's make some functions to get our various IDs from that. Now we kind of want to get the, maybe let's make a new type for this. Pub const IDs equals struct. We just call it base. Pub fn window. Yeah, this should work well. So we'll have window be, what was it now? It is the base. So we just return base. IDs equals IDs. So now we just do IDs.window. And then this BGGCID, so we can make a function for that. So that's the background graphics context is what that stands for. What was it, +1, I think? And then foreground is +2. IDs.bggc. And then IDs.bfggc. Okay. IDs.fggc and IDs.window. Okay, so then we'll just save this IDs as a field. It's after screen. Seven. Hey, Twastip, X11 image viewer neat. Yeah, X11 will be the first one, but yeah, hopefully I can get it working on like Wayland and Windows and Mac and all that stuff too. Let's see how far we get here. IDs, does that need to be like that, maybe? Yeah, okay, 238. See self.IDs. Actually, let's have render take IDs at this point. IDs. Drawable. So we'll just change this to IDs.window. So this one. Okay, that's probably good. FGGCID is going to be IDs.FGGC. Okay. We're going to start out with PPM images. So I just made this little like simple program here to generate an image. So if I run that gen image, it prints it to standard out, but if I send it to like image.ppm, then it just generates this. And then I can, right now, before I started refactoring it, we could actually display this image. I just generated it in memory, but we can display it via X right now. So after I get done putting all the X11 specific stuff into its own file, we'll just get this displaying from a file. And I'll probably use the Zig IMG repository to like add more image formats. So yeah, that seems like a pretty reasonable progression in my mind. Just got to finish this refactor here. 238 font dims is now a member variable. Okay, this one's using the background graphics context. Okay, and then window width and height. So we'll probably need to save those as variables, I'm guessing. Okay. So I need to pass those in maybe. Sure, why not? Why am I checking if something is Windows with X11? No, I suppose you could run X11 on Windows. It's definitely not common, but definitely can. And with ZigX, you should be able to do it no problem. Okay, so now we're back into our main file, so I think we're getting close to our refactor being done here. No field or member named window loop. Okay, what did we do wrong here? Pub fn window loop should be state. Is it because it's, yeah, it's because it's const. Okay. Oh, still, oh, we need a try. Okay. 63. These need to be U16s, so maybe we should just take U16s in our init function. Maybe that's the play. Okay. Got to return 1 somewhere. Okay, so this would be if we get a bad reply. So we could do return error dot X11 unexpected reply. Is there another return 1 somewhere? There is. X11 buffer too small, sure. And then this would be just a return. So our window loop can actually exit. Expected U32 found I16. I think these window width and heights should probably also be U16s. See what it does with that. Might need to actually cast these to I16s. See if that does the trick. Yeah, I think it does. Those are pretty long lines now, but not going to worry about it this second. Expecting 6 arguments. I think we need to pass in the width and height now. Yeah. Okay. Expected type U16, found U32. Those should be U16s. Okay. And we passed something in the wrong order down here. Socket, max request length, IDs. Yeah, it should be like that. Okay, back to main. Let's see. Function with non-void return type. Return 0. There we go. See if we still work. We still work. Refactor was successful. We can still show our image there. And this is basically our factored out X11 backend. So on Linux, we would probably do something like check if Wayland, I think it's like there's a Wayland env variable. And if that doesn't exist, then we would try the X11 backend and so on. Okay, probably we could, the next thing to do maybe would be to actually read the image file in and send it to the window maybe? Would that be the play? So how do we want the image viewer to work? So if you like open the image viewer, I suppose like if it's a graphical, you could have some sort of a UI where you could select an image to view. But let's start out simple. Let's just take the image on the command line as a parameter, and we'll just display the image. So assuming that interface, probably we'd still want the backend. You'd be able to like basically like you have the backend, you tell it to create a window, and then we could just say, hey, here's an image, display the image. And that could be our first pass. And you could also get fancy, like if the image file doesn't exist or if there's an error loading the image, you could have the window be like report error or something. So maybe that's what we do. Yeah, that's probably a good way to do it. So we create the window and then we load the file. Is that how I want to do it, or do I want to load the file first? Let's load the file first starting out, but it probably won't stay that way. So var, let's get our arguments. I have a way of taking command line arguments I've been using everywhere. I'm going to copy and paste that here. Okay. Let's get my OOM function. Okay. So you've got like special handling for Windows, but it basically gives you like an iterator over all of your arguments that won't like allocate any memory on POSIX, but it will on Windows because on Windows you have to. But yeah, there's our command line. So basically there's special handling for Windows, and then on POSIX you just use standard OSRV. Returns a slice basically of all your arguments. And it creates an allocator just for the arguments for Windows. So let's come down here. There's our arguments, and we'll say if args.len equals 0. For now, we'll just print an error. Or we can do this. Usage image viewer. What is the name of our, is it image viewer? It is, okay. Okay, so we'll just do that, and then we'll return an error. args.len is not equal 1. Then we'll print an error instead. Okay, const file name equals args0. And then we'll, let's see, how do we want to read the file? Maybe we just read it into memory starting out. I think I have like a read file function or something. Yeah, read file. Okay, so we'll just do const content equals read file, file name. Probably we'd want to like handle some errors, like if it doesn't exist, like report a nicer error or something. Okay, see if that still builds. Probably won't. Expected type, yes. Standard mem span. Okay. Can't do a try and a catch. Oh, okay, so build run foo. Should give us a stack trace. Yep, file not found. Let's make that error a little nicer though. Let's do that so we don't get that full stack trace with all that noise. Error.file not found. To do maybe display an error via GUI. But for now we'll just go fatal. Image file. Actually, we just do all the errors like this. Let's just go failed to open. Oh, let's get rid of the switch. And actually, let's just get rid of this function. Failed to open. Sometimes it's like faster to just type things out than to copy paste. So it's like I have to type the same thing out a few times here, but this is faster to do that sometimes. Failed to open with. Okay, so we'll go file name, error, and I think that's all we need to do. Break, block, file, need to end alloc, and that's it. So now our error should be a little nicer. We still need our unused variable hack for a second. Let's get rid of that. Expected union, got the try catch again. Error is discarded. Failed to open foo with file not found. Perfect. But now let's pass in our image. Okay, now that's not actually the image, even though that is the same image. That's not actually from the image file. So now let's actually pass the image file somehow. To do select the right backend. And then here, let's add a to do, maybe display an error in the GUI. Okay. Next is we need to pass this image to our backend. So let's go x11 state dot set image. I mean, we could pass the image to the construct. Well, but the plan is that we could construct it maybe and then pass an error instead of an image. So, but we could also pass the error to the constructor. Yeah, let's just pass it to the constructor. Let's keep it simple. That's the simplest thing to do. So let's do that. So we got an allocator, window width, window height, and then image content. Could like pass an image format too or whatever, but let's keep it simple for now. Image, or let's make a like a type for this. Image.zig maybe. Or let's make it a capital image. Okay, so the image will have a width. Let's do this for a second. So we got xy.zig, pub const, pub fn xy, comp time t, type, struct, no, type, return struct, xt, yt. Let's add an init as well. These little things can sometimes like make the rest of your code like just a little better, a little nicer. So let's just go ahead and do it. It's worth it, I think. So we're going to be using this XY thing, I think, quite a bit. Okay, so now we've got our XY. Before I move any further, I think we should probably get that XY thing in our X11 backend. Okay, let's comment this out. I hate when I'm about, like, I start a change and then I realize, okay, I want to make this other change first, and then I have to undo that change before I can get it to build again. But that's okay. Width, so this will be a window size, XY U16. Equals import xy.zig.xy. Okay, so 165. Window size equals window size. Yeah, I should have done this earlier, but that's okay. Window size.x, window size.y. Okay, and then main. It's also maybe let's const xy equals xy. And also keep those as constants maybe, because no quick fix list in Emacs to jump to errors. Like, are you asking if there's a way to like select this and like go to that location? Because I don't know if there is. Do you know if there is? I do use Emacs quite a bit, but I'm definitely not a power user. Yeah, built or but, yeah, but as a dedicated window, like it's like a separate Emacs window. Do you know like the commands to do it or anything? I could try it out. Common use of Vim's quick fix. Does the same thing and is built in. Here's a demo. Compile command. Oh, okay, hold on. What's that compile command? Wait, how did he do that? Emacs compile command. What is this? The variable compile command. Compile command. Huh? Okay, so if you go mx compile, oh, and then you pass a compile command. Zig build, save file, yes. Wait, why is it asking me if I want to save the file? Oh, okay. I think it might be working. So 237. Oh no, oops. Wait, no, I should be able to go here and press enter, and then it goes there. Okay. Expected 6 arguments, found 5. Okay. Yeah, let's try it out a little bit. But this is my first time using compilation mode. You should be able to jump to the red mark. Okay, yeah, I'll have to figure out what that is to jump to the red markers. Window size. Okay, so then I think compile. I wonder if there's like a compile key combination. Emacs compile command keyboard shortcut. Okay. Looks like there's not like a built-in one, but if I do that and I just press enter twice, it should just do it. But if I just press enter and Emacs compile output jump to red marker. You can move. Okay, meta n. There we go. Okay, let's experiment with it a little bit. Oh, there's only one instance. Okay, so compile. Okay. Interesting. All right, so we've got our XY, so we did a bit of a tangent. What were we doing before that? Let's go back maybe to main for a second. I think we're about to pass in the image file. Let's go ahead and do that then. Oh, that's right. I was gonna add an image.zig, and it was gonna have like the size. What should this be? Should be support more than 16-bit image size images? 65,000? Yeah, I mean, sure. Let's do U32. And then bytes. I don't know. Sure, I guess. Okay, let's pass in an image then. Const image equals import image.zig. Okay. And then we need to pass that when we create. So let's go dot size equals. Oh, no problem, Batuba. We'll see you next time. Thanks for that suggestion. X equals. Okay, so our image is currently hard coded to be 256 by 256. Let's see. And then, why does this formatting look weird to me? It's to be like this. Dot bytes equals content, I think. I think that's right. I don't know. Oh, I need to do compile. Okay. Okay, so now we have to use the image. So probably in the X11 case, we would just save it as a field, and then our window loop would use it. XY. Okay, so we should be working again. Okay, so now let's display our actual image instead of the canned one we're creating here. Let's actually really quick change this maybe to like black or something, or let's get rid of the, let's just do the red, I guess. Okay, so we're displaying the blue thing, but we want to be displaying our image file now. So how do we do that? I think we just call send image. Let's just get rid of all this code. We don't need it anymore. We pass in the, let's switch to 0, 0. Let's see, might be nice too if you change the variable compilation auto jump to the first error to a non-nil value. Emacs automatically visits the locus, probably focus, of the first error message that appears in the compilation buffer. Oh, change the variable. Okay, I see. So you're saying once I compile, the cursor will jump to the first error automatically. See, it was called compilation auto jump. Okay. Let's try that. Dot files emacs init.el. Let's see, copy, paste, T. Okay. Did I forget how to reload? Emacs reload init. Load file. Okay, let's try that. Okay. So now when I do compile, okay, yeah, it didn't change the active buffer to that, but it did put the cursor on the first one. That's cool. Nice. That is definitely an improvement. All right. Use of undeclared identifier width. This should be self.image.size.x. And then the stride is going to be So we actually have the image file that we read in is different from the format that X11 is expecting. So we need to introduce the concept of image formats now. So let's go ahead and do that. So we'll call this 24 RGB. I think that's somewhat, or we could say RGB 24. Be our first one. Okay, so what's a clever way that we could do this? Probably we'll start out doing like the simplest thing, which is just to do a format conversion to what we currently support. Because right now X11 is basically RGB 32. So we'll just convert it, I guess. So let's get rid of this image. Let's do image size. Actually, we don't even need to save the image size. Actually, we don't even need to pass the window size either. We can just not pass anything. So let's get rid of this window width and height. We don't need that. Get rid of that. Get rid of that. Okay, so we're going to have an image size, which I believe was an XYU32. And we'll just also make that the window size. Just make them be the same size. And then we want RGB 32. I think that's all we need. We also need, well, we'll just assume that the stride is 4 times the width. Okay. So we'll just convert the image in the init function here. So we'll just set it to image size.x and image size.y. .166. Let's see, window size we no longer have. We don't have image anymore either. We do have image size, so that's going to be image size equals image.size, and .rgb32 equals, we'll just set it to, I don't know, like an empty array for now. Okay, and then send image, we'll need to do this. Okay, so render now needs, we'll just maybe call this size instead of window size. Okay, and then we'll just call this size. Maybe we call this size XYU32. Okay, stride, we need to calculate that. Should just be const stride equals 4 times size.x. 318, and this should be RGB 32. RGB image, RGB 32. Okay. Something wrong with my main file. What did I do? Missing format. RGB 24. Okay. Expected U16, found U32. Oh, wrong file. Oh, see, I forgot to do the compile thing. Okay, compile. There we go. It'll take me like at least a few tries to like get that muscle memory adjusted. Okay, so this is, the problem with this is that it's now a U32, so I think we're fine just doing a cast here, just for now. Oh, compile. Okay. Oh, interesting. I think Emacs automatically switched. Okay, let me try this again. So if I'm here and I do compile, yeah, okay, it automatically jumps to the error. That's really cool. Okay. So window size is missing. Window size should no longer exist. Okay, expected 6 arguments, found 5. So this should now be image size, I think. And then this should be self.image RGB32. I think I'm sometimes using IMG and sometimes image. Let's just use the same one. Okay, no field image RGB32. What did I call it? Okay. No field RGB32. Expected XYU16 found XYU32. Cool. Okay, so I think that probably failed because I'm passing in like nothing for the buffer. We need to actually pass in image, image.bytes. Is that what I called it? Okay. Okay, yeah, so now I think we haven't done the format conversion. So this is what RGB 24 looks like when you interpret it as RGB 32. So let's do the conversion here. So we'll do const RGB 32 equals allocator dot alloc u8, and then that would be 4 times image.size.x times image.size.y. We'll do a try on that. Oh, I know what I'm thinking now. We probably need to do these as error differs. So error differ, yeah, I think that's what we want. Okay, so now we're actually doing some tries. Well, we were already doing some tries, but error differ allocator.free RGB32, and then we'll do that as well in the dinit function. Oh, this shouldn't be a differ. Let's see, self.allocator.free self.image RGB32. Okay. We'll just always do an allocation and a copy for now. It's fine. So then we'll switch on the image.format.rgb24. I'm gonna say we could do this in like another file, which it should go in another file, but we'll just put it here for now. So how do you do this? For var y u32 equals 0 while y is less than image.size.y. Var x u32 equals 0 while x is less than image.size.x. Should be a less than x plus equals 1. Okay, and then we can do something like var source off dest off, and then dest. So what is the dest? RGB32 dest off plus 0 equals image.bytes source off plus 0. And maybe I should do a mem copy here. I don't know. Dest off plus equals 1, then we set the fourth one to 0, I think. Or FF, I don't know. I don't know what X11 expects. Source off plus equals 3. Okay. I think that's right. All right. I'm anticipating 3 errors. There's always 3 errors. Oh, X call. Oh, 1 error? Nice. There we go. So I think we did it. I don't know why the image is shifted. It's a little weird. Oh, it's not shifted. It's because we're rendering it at... Oh, actually, I don't think we're rendering it at offset 10 anymore. Let's get rid of this other stuff that we're rendering. Let's just remove it. Get out of here. Oh, font dim is no longer used. Well, we might want to render text at some point, so let's not remove it yet, but what is this little green? Is that in the original image? No. Is it a problem with my conversion function maybe? RGB 24. What did I do here? Really quick, am I able to close the window? Yes. Okay, closes nicely. Let's see, not sure, but might be quicker to do RGB. Oh, yeah, that would be 1 line, I guess. 0 dot dot. Would it be 3? Yeah, missing that dot dot. Okay, what is going on here though? Let's see, what's the way I could like verify where the error is at? Oh, wait a second. I don't think I'm offsetting the file. Nor am I getting the... I'm also not getting... Yeah, I'm not reading the header and I'm not actually reading the ppm file yet. So var line it equals... Or what's the best way to... Let's look up the ppm format here. Magic number for identifying the file type. Okay, so let's read that first. If not standard.mem.starts with P6 image file does not start with, it's not a valid ppm file. Okay, so we should be able to like give it some random file like main.zig. Okay, it looks good. May have replaced width with something.y. Oh. Okay. Could have been in here. Let's just look at X11 backend. Size.y? Okay, so wouldn't it be this one? Is it this one? think it's this one. I think these are all good. Yeah, no problem. I want to double check this send image with media stream, video, server. Let's see what this one does. Where do I use width? Oh, actually, you might be right. Wow, that's a that's a good catch there. Okay. The X and Y were the same, so that actually wasn't the error. But I think you did catch an error that could have bit me later. Very nice. Okay. So back to here, we've actually the offset is because of the header, so that was the problem. So if you look at image.ppm hexel mode. So it's P6 and then a new line. Well, we can double check the format, I think. So your magic number, white space. So we can use standard mem tokenize for this. So let's do that. Maybe we put this in a function like, or we can put it in our image file too. Init ppm content. Okay, so maybe we like return an error instead. So return error dot invalid magic. Okay, so I think this is still failed to parse as a ppm file with. Okay. It's gonna, I know I'm gonna need that. Also, do you need to zero init every 4th destination byte? I think I'm doing that. Let's double check. Am I forgetting the name of the file? X11 backend. Oh, you're right. I'm not doing that. Thank you. +3 equals 0. Okay, should be good. Thank you for that. Compile this. Whoa. No, let's compile. Okay. Const std equals import std. Okay. All right. So invalid magic. The next thing to do is var it equals std mem tokenize u8 content and then any white space. What was the white space? It said. Blanks, tabs, CRs, and LFs. So that's blank, tab, CR, LF. Okay. So while it.next. What do we call this? Token? I don't know. Got token bytes. Oh, you know what I should do? Compile should do zig build and zig out bin. It should be my whole image viewer, image.ppm. Yeah, let's try that. Okay, function with non-void return type, return error dot to do. Okay, cool. So we got token with 2 bytes, 3 bytes. So this should actually be content 2. Okay, so now the 3 bytes, we want to, let's see. I actually don't want to do this in a loop. So const width. Width stir equals it dot first. There's actually a first now, I think. Actually, I think I just wrote this code. I did. Const width equals stood format parseInt, and we'll parse it as a U32 width string. If it doesn't work, then we can do a return error dot invalid ppm. Maybe we do invalid ppm, bad magic, bad width. How about that? Catch. Okay, width unused local variable. Okay, first. Oh, tokenized. Maybe tokenized doesn't have first. That's just split iterator. So we'll go next, or else invalid. We'll just say invalid ppm at that point. We could say too small. I don't know. Okay, so now we've got a width. Let's see what that looks like. Width. Width equals 256. Okay, and then we need the height, so basically the same thing. Height. Width, height, okay. And there's one more thing we need is the maximum color value. So I think we just do the same thing. Height, max, color. Bad max color. Oh, I got 2 more. Okay, max color 255, and then what's after the max color? Is it more white space? A single white space, usually a new line. Okay. So how do we get that? Const data offset equals max color stir dot len. So I think it would be const save max color start equals it dot index. I think it's like that or something. We can take a quick gander. Token iterator. Peak, rest, reset. We could maybe do rest. Maybe that's what we want to do. const data equals it.rest, and then we offset it by 1 for that white space. That might be what you're supposed to do. Return dot size equals dot x equals width dot y equals height dot bytes equals and dot format equals dot RGB24. And there you go. There's a ppm parser. Maybe add that to the Zig IMG repo. I don't know if it has a ppm parser in it, but reading more about compilation mode. G, rerun the last command whose output is shown in the compilation buffer. So G, so you're saying if I go compile and then I do meta G, or if I'm in there, I do G. Ah, okay. If I'm in there, I can just switch and do G. Oh, nice. Okay. Cool. What's the problem here? Root has no member name build. Okay, I don't know what's going on with that, but is it? I think it's because I probably had like a different file open, just running it from a weird directory. Okay, unused local constant max color. Oh, if max color does not equal 255, error dot unsupported ppm max color. Sorry if not useful, but yeah. No, don't be sorry. Keep the suggestions coming. Max color start. Yeah, I'm not using that anymore. Guess if I go G, yeah. Okay. So now I just need to update main, I think, to actually pass this image instead of the fake one I created. This could maybe be one line now, but compile. Success, but it quit. I think it crashed. Index out of bounds. Okay, so it doesn't. Maybe I'm off by 1 on my data thing I did. Offset equals. We could do this. $16, is that the correct offset? So that should mean the data should start here. It's not, it should be 15. So I think we just need to do this. Actually, this is telling me that this rest is not what we want to actually do. Because if the first pixel value so happened to be a space, it would skip over it. That would be a bad bug. So let's go actually figure out how this should work. Token iterator. So you've got an index, peak, rest, reset is split byte. Okay. So probably what we want to do here is before we get the max color, we'll get the start. And then after we get the max color, we'll get the offset using max color start plus max color stir.len plus 1. I think. Nice. We still have a green line for some reason. We don't have that in the original image, do we? No. Is this right? This should be 15. Double check that. 12. Okay. Why is it 12? Maybe I need to get the offset after. Oh, the index is probably, yeah. I think I need to get it after. So max color end. That's probably what I want. Is there a little blue on the left there? 13. Okay, still not quite there. Man, off by 1 errors. Let me double check. It's supposed to be, yeah. So this is a new line. So it should be 15, I believe. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, it's supposed to be 15. Let's see, mem.zig. What is next doing? It's calling peak, and then it adds the result length. So we could do something like, const max color offset equals pointer to int max color dot pointer minus pointer to int. I don't really like doing pointer to int because pointer to int doesn't like work at comp time. Not that like, I mean, like you could theoretically want to parse a PPM file at comp time. Come on, what's the right way to do this? There's an index. What does rest do? It says it gets the index is split byte. Okay. So it does skip. Okay, let me. So it's giving us the offset of 13. Why is it giving us 13? What's at 13? So this is 15, 14, 13. Oh, that's interesting. So it points to the last character. Really? So it must like immediately increment the index. Like when you call next, it calls peak. So what does peak do? Doesn't seem right. Index. Oh, it's actually 12, isn't it? Let's double check. Index equals, yeah, it's actually 12. So what's at 12? I think that was like the middle of the max color string. Nine, 10, 11, 12. Why is it at 12? The heck? Huh. Oh, whatever. Let's just use the pointer to end trick. Content outputter. So this should actually be 11. It is 11. Okay. So it's max color offset. Dot len. Okay. That should be correct. Finally, there we go. So there's our image viewer. We're able to display a single ppm image, and if we change the ppm image, it should update our, I don't know, can we do something like plus 100? Okay, so our new image looks like this. And does it look right? Wait a second, that's not right. Did we mix up our RGB values in our, must have mixed up our RGB values somehow. Let's see. Let's just do like red maybe. Okay, so we've just got red. Does red work? No, red is not in the right space. So maybe, I think X maybe has some funky color ordering or something. Okay, let's go back to dest off plus 0 equals image.bytes source off plus. So if red is turning into blue, that means the first channel is the blue channel. So this needs to be from the blue channel, I think. I bet you it's reversed. I bet you that's what it is. 1, 2, 1, 0. Okay, let's try that. There we go, it looks better. So let's go back to gen image and do green. Let's see. Does that show us green? Looks like it does. Let's see, what's this comment? Token iterator index will be one step ahead after you call next. So think you'd have to save the index before calling next. Okay, let's try that. Let's see, what file was that? That was an image. So you're saying if I save it here, see what value we get here. Eight. What is it? 8. Image.ppm, hexel node. There. Yeah, I think it's, I don't even know what it's doing. It doesn't make any sense to me. Why is it at 8? Oh, you know what it is? It's because I've started at offset 2. That's what it is. So I need to add 2 to everything. So this is actually at offset 10. So I think you're right, though. It does save it after the value. So I think what I can do is, let's see, after we get the max color, we just add 1 to whatever the index is, but we have to add 2 as well. So that was the issue there. Maybe what we should do is do const file content and then const content equals file content 2. And then we do this. I don't know, no magic or after magic. I'm trying to like make it so this mistake is really hard to make again. So we just do after magic content, and then I think we just need to do it.index +1. Let's try that. 15. Okay, I think that's right. And we can just do after magic instead of after magic content. Okay. I think that should do it. That's a little better. What was I just going to finish up? Oh yeah, so now we want to do blue. So we got red and green working. Green, let's make sure blue's working. Okay, we've got a blue image. Do we have a blue image? Yes, that matches. Okay, let's do the full image again. RGB. Sig build. There we go. I think that's right. This isn't actually a very good image. It's a cool looking image, but it's not a very good image for testing. Maybe let's make it a little better for testing. Like if we had like 10 rows of red or something, like we could go if x mod. See how would you do that? X mod 30 is less than 10. Mod is less than 20, else. And then we'll say var r u8 0. So we'll zero everything out. So if it's 10, then r equals f, g equals f, or blue equals f. Okay, let's try that. 3 u8 RGB. Oh, we want to do a gen image. Okay. What happened to our image viewer window? Oh, I was expecting them to be horizontal. To do that, you'd have to do this. Okay, let's make it like, I don't know, 20 pixels wide each. So 20, 60, 20, 40. Okay. Yeah. Maybe you want like black and white in there too. I don't know. I mean, getting RGB all, I mean, black and white would be good to do. So maybe we do like 100. B, if it's less than 60, if it's less than 80, else. Okay, so we'll start red, green, blue, black maybe, do nothing, and then white. There we go. Looks like some weird flag. Okay. So we're able to draw PPM images to X11. Let's go ahead and make our first commit here. Let's see. We've got our Git repo step. We've got our image file. Got README build. We need to ignore the dep folder. We've got our gen image. Maybe we call this gen, so gen test image. Maybe, see, you're never going to want to like actually go to standard out, so let's just write it to a file instead. Var file equals center fs cwd dot create file. That should be all we need to do there. And maybe we call it test image, I don't know. Try. Okay. So we should be able to do our old command, but with test image. Okay. So let's go ahead and add, maybe we don't need to add test image. Let's remove image.ppm. Okay. Image.zig. Let's get rid of you. Okay, here's our main file. Doesn't look too bad. We've just got command line argument parsing. We parse a file, and then we create a backend, which right now is we just have X11, but hopefully we'll add more. Let's clean up this file a little bit. X11 backend. We had some weird allocator comment somewhere. Let's get rid of that. These are all like window options. I'll just leave those. I think that was like stuff I don't quite understand, like about the X11 protocol yet, but yeah, we're hard coding the depth to 24 pixels for now. That's okay. Can always fix that later. We've got this common file. It just makes an X11 connection. We've got this XY file. Let's add zig cache to our git ignore. Zig cache, zig out. Okay. Initial commit. All right. I think I have a little bit of energy left to do maybe another feature here. My initial thought is adding the zig image repo and just basically using that to support any other image formats that it supports. That shouldn't be too much effort. So let's see if we can get that accomplished here. So zig img 2 days ago, yeah. Let's see what it supports. It supports reading Ports reading ppm. I wonder what it's ppm formats ppm. All ppm. So net PBM. Interesting. I wasn't aware of that name. Adapted from adapted from Master Q32's Felix's. Felix writes a lot of code. Let's see how they use tokenize. I don't see it in here. Oh, there's the P6 magic. How do they actually parse number? How do they do it? Parse number. Okay. Yeah, they could probably make this a little bit smaller if they used tokenize maybe, but that's okay. Cool. So let's see. How do we use this? Okay, so they just cool. Let's do it. So let's add it. So we still got the ZigX repo. Let's add their repo. Zig image. Let's get the actual GitHub URL. Okay, do they do like releases or anything? No, they don't do releases. December 21st, so 2 days ago they merged, from Felix, okay. Cool. Let's get that SHA. Just use the latest, I guess. Let's add this as a dependency. Zig image repo.path. Okay. Build. Okay, downloading the repo. It's downloaded. Let's go ahead and add it as an import. Where should that go? Maybe here. I call it Zig image or just call it image? I'm just gonna call it image maybe. Okay, so we're able to import it, it looks like. Or, no, actually not, because we're not using it yet. Let's go ahead and see how we parse files with Zig image. Is there anything in the README? Nope. Let's go ahead and look at the index file here. Okay, so it looks like we can use .nnetpbm to do ppm files. And let's see how that works. We do parse header, so it wants its image stream, so they have their own like reader type maybe. Where's the function to load? Load binary bitmap. Parse header. Let's see, parse number. What are the public functions? Pub. Oh, interesting. So this PBM format, I guess, also supports a bitmap. Okay. Oh, here we go. Oh, okay. So ppm is the 3 and the 6 version. Very cool. Okay, so I think we can do, let's see, img.netpbm.ppm. I think that's right. And then this is basically our API. Read image, okay. So you pass an allocator and you pass a stream. Okay. So let's try that. And it's, yep, returns an image read error or an image. Okay. Image2 equals dot read image. Where was our arena.allocator and a stream. We're just going to pass something like that for now. Okay. Okay, so we need to create a stream source. What is this stream source stuff? io.streamSource. Okay, let's figure out what that is. Guessing there's going to be something in here. Stream source. Oh, stood.io. Oh, it's a stood.io stream. Is that right? Var. I think probably we could do like a string reader equals stood.io. Seekable stream, fixed a buffer stream. Maybe that's what we want. Content, probably something like this. Content stream. You can use image.image.fromFilePath. Let's find that one. From file path. Okay. So I don't actually need to read the file. Let's actually let's keep that there for a second. And then image is, I'm guessing img.image. Let's try it. Var file stream equals img.image.fromFilePath file name. And it needs an allocator as well. Okay. Let's see what that does. I'll probably need a try or something, but just add a try here for a second. Oh, shoot. I think they're on a different version of Zig. So we might need to update. Yeah. Yep, they are. Let's do that. We're going to have to make a change to ZigX first. So we'll update ZigX. Font custom 200. Okay. ZigX. All right. So make sure we're up to date. ZigUp master. Zig build. Okay, so we should get an error, I believe. Yeah, so we need to look for ever we're using field type. Whoa. What is this big old file? It's because I have Lola in here. Something that it's Felix's scripting language. I think that's how you do it. Is that right? I think I can just remove Lola. Can always re-download it if I need it later. Okay, so I'm just using it in these two files. Field type, replace it with type. Emacs's syntax highlighter is not happy with that. Oh, it's also in bog, but I don't need to change that. Okay, I think that's all I needed to do. Let's make sure there's no other like weird things that are broken. RGFN main. Let's run this one. Okay, that one seems to be working. Zig run get server font names. Okay, that one seems to be working. Graphics, is that a? Oh, got a pointless discard. Let's fix that. Also 252. Oh, hold on. Oh, it's because it's now used. I see. Okay. Missing struct field depth. Sure, I guess. I don't know. Line 172, so we're not handling a switch. Which one are we not handling? Mapping notify. Why is that one? Why is this one having to handle but nobody else is handling it? Oh. They are, it's just mapping. Okay, so we're just going to copy this, paste it into graphics. Good. Log it. Yeah, I think this example has probably been broken for a little while, but should be key code now. This one I'm guessing is the same. Okay. Another example is to get pixels you can use image.raw. Okay, cool. Cool, that might come in handy. Probably need that in a minute here. Okay, graphics. Okay, get server font names we already did. I think we did example. Okay. Query font. I think you have to give it a font name. I think fixed is probably one. Yep. Okay, that's working. Font viewer. Make sure that's working. This lets you view all the fonts on the X server. So it looks like that's working. Good. And there's input.zig. That's what this is the last one. Segfault. I don't know if I'm gonna. I don't know if we need to fix this one, but we'll take a quick gander at it. Oh. The compiler is segfaulting, trying to compile it. That's not good. I'm not going to worry about it though, because I need a debug build of the Zig compiler to be able to fix that, and I don't have one right now. So we're just going to ignore it. Zig update, field type renamed to type. Okay. Push. Let's get our SHA. Okay, let's go back over to our other project here. Let's update our SHA for ZigX. Okay, and let's build again. Okay. just re-download the repo automatically so that we get the update. Okay, so back to actually using Zig IMG. Expected stream source found source image. Okay, I'm guessing there's like a .stream or something on image. Let's see. Oh, Zig image is what I was. Okay, so they have an image.zig somewhere. Source image. Yep. Okay, let's take a quick gander at this class. So it has an allocator, width, height, pixel storage, and animation. Okay. Oh, animation. That's interesting. Okay. Okay. Cool. From file path returns an image. Okay. So, how do we get a stream? Oh, you can do from memory as well. How do I want to do this? I think I actually want to do from memory so I can print a nice error message to the user if the file fails to open. So we'll do from memory content. Okay. All right. So how do we get a stream out of this? Write to memory. Stream. How to get a stream. Stream. Okay, there's the stream type. Oh, you know what? I'm doing this backwards. I already have a file, don't I? Image 2. Yeah, I don't need a stream. Okay. So I have loaded the image. I don't know how it tells what kind of image it has. What is IO? Is IO? Okay, yeah. How is it telling what kind of image does it? I'm asking this to myself because I'm wondering if it uses the file name to determine the image file type, but it actually doesn't look like it. It throws away the file name by the time it's actually reading it. Find image interface from stream. Okay. So it's actually reading the image content to determine the file type. All right. That's probably fine for now. I think we'll just let it figure out the file type, and then if we need to enhance that somehow, we can later. We'll just use that for now. Now that we have an image, though, we need to get the format. So how do we get the format? Pixel format. Okay. So what is pixel format? Pixel format is an enum. Okay. Oh, very nice. RGB 24. Okay, so we can remove, let's just remove that. We don't need it anymore. Maybe I like that error message. I don't know yet. Catch error. Failed to parse. Failed to load image. Okay, so we pass the file name, we give it an error. Okay, so like what happens if we try to I'm gonna have to add the dot size equals. Okay, how do they do their size? Width. Okay, so it's just a int cast image2.width. Y image2.height. And then I need bytes. Image2.raw bytes. And then dot format. We're just going to say RGB24 for a second so we can compile. Okay, that's working actually. Let's give it like a random file, like main.zig with unsupported. Okay. Okay. So now let's actually get the format. Does Zig image have format conversions is the question. If it has format conversions, that'd be really nice. Convert, let's see, RG convert, conver, Zig image. I see some tests. Convert. Helpers. See, where's the conversion being done? Is it just single colors? Color? Where's color? Okay, so color is it's an RGBA. F32, okay. So RGB methods. Okay, this looks like single colors. It might be okay. Pixel storage. Oh. Oh, interesting. Okay. Oh, pixel storage iterator. Ah. Okay. Let's go back here. So for now, we can say if image. Let's get rid of image2 here. Format does not equal .rgb24. Fatal. Unsupported image format. Okay. The field name format, I think it was like pixel format or something. Now let's do like this. Okay. Image.test image.ppm. Okay. Let's find another image to try to display. Cool image. Yeah, that looks cool. I like that. Save image. Get cool. Okay, save it here. What type of file is it? Huh? JPEG, okay. Geez, documents. JPEG, okay. Save. All right. Cool.jpg. Failed to load with unsupported. Oh, it does not support JPEGs. What does it support? Let's figure that out. All right, BMPs, okay. PBMs, PCX, PPM, oh, QOI images, okay, could try that. Let's maybe find a PBM image. Or a BMP, I mean. Let's see, there's a way to filter BMP, maybe just try that. Oh, that's a big image. Let's find something smaller, maybe. Do something with color, come on. Batman symbol. All right, is this Batman symbol a BMP file? WebP. I wonder if that'll work. No. Okay, we need a BMP image. BMP files. Okay, yeah, sure. Microsoft bitmap files. Think Tools has file type option. Yeah. In Google, yeah. Yeah, I couldn't remember where it's in Tools or something. Unsupported, come on. That's a bitmap, isn't it? Bitmap, yeah, seems like it is. Hold on a second, why couldn't it load that one? I wonder if it has any test files in here. Okay, what about QOI? Test images. Okay. QOI test images. Move. Okay. QOI logo. We didn't try. Okay, so it does support PNGs. Very nice. QOI, unsupported image format, RGB13. Okay, let's go support that image format. So we need to do some sort of conversion. Pub fn init. Now we could have the Zig image type used directly in the X11 backend, and that's one way we could do it. Is that how we want to do it? Potentially, yes. Is that how I want to do it starting out, though? I'm actually tempted to not do that yet. I can always do that later. I think you can use iterator and convert to different format on the fly. Yeah, what's interesting about that is I could actually not do any image conversion at all, and actually do the conversion while I'm sending it over the X11 connection, and just keep the bytes as they exist in memory, and that could be potentially the most efficient way to do it. That would take a little bit more work because my X backend has some logic around calculating how many bytes the rows are going to take and stuff. But I think I might do that as an enhancement later. For now, I think I'm going to keep my own image class and my own format, and then maybe do that a little bit later. So let's add in a init here, and we'll import Zig image in this file for now. And we'll take an image, image.image, and we'll return an image. Okay, let's go back to our main.zig. And I think we can just say, yeah, we can just do 32 as well. So we'll go 32. Let's see. So we want to do image.init image. Okay. So if it does not equal switch image dot pixel format dot RGB24. Actually, we just want to return this. Size, bytes, and then format is the only thing that changes. So RGB24, we return RGB24. It's RGB32, we return RGB32. Otherwise, we will to do support pixel format okay. That should do for now. Okay. So I should get an error in my X11 backend saying it doesn't support RGB32 yet. Yeah. Okay. Yeah, let's go ahead and move this to a different file. No, not yet. Not yet. Okay. 25, what is wrong with this? RGB 32. Saying it doesn't exist. RGBA 32. Okay. Okay. Let's get rid of this. no, we don't want to get rid of that one. Okay. I think it worked. Let's try the PNG maybe. That seems to be working. What else do we got in here? Dice. Ooh. Very cool. What about the QOI image? Also working. Codim. All right. Let's see, what is it? Codim 23. QOI is also working. What else do we got? QOI logo, we did that one. Test card. Ah. QOI as well. Test card, what else do we got? Test card RGBA. Wikipedia. Okay, very nice. I think that's a committable set of changes here. So we're still using our custom image, which I don't know if we want to do that long term, but it's okay for now. We added Zig image as a dependency. Let's go update main.zig. Can probably remove our own init ppm. Yeah, we just don't need it at all. Remove. Okay. And then we added a new conversion function for X11. This like conversion it's kind of like X11 specific, but let's at least like put it into a function maybe. I don't know, let's put at the end, I guess, fn convert image. I don't really know. So we're going to need an image. Actually, maybe we just get rid of our image type. I think it'd be pretty easy to do that. This may not need a try. Just panic if it fails. I don't think it should actually fail for any reason. Okay, so image. So we need like a destination. So call it destination RGB32 maybe, just to make it really clear. Defer image.dnit. Okay, let me see about that. So you're saying here I would do defer image dnit, right? Okay, expects 2 arguments, RGB32. Okay. All right, that's a little better. At least it's in a function now. So let's make this a commit. Use zig image. These are all just files, right? Let's remove the ones that. Okay. Yeah, let's make a commit here, add zig image. And then let's remove our own image file here. I don't think we're going to need it. All right. So we don't need that. We'll go over to our X11 backend and actually just use the zig image. Const image equals import image. Do this const image equals image.image. Okay. Image.width and image.height. Okay. .168. Okay, image.width times image.height. And it would be cool, like instead of allocating a buffer here and then doing the conversion, it would be cool if we could just do the conversion on the fly. We wouldn't have to allocate a new buffer for it. 180. I mean, actually, like I'm using xPutImage here, which means I'm sending the image every time I'm rendering the window. I should probably be using like a shared memory extension instead, though, or like some type of a buffer, so we only send it over once. But that would be an improvement to where we're at now. It also wouldn't work remotely. With this actual X11 application, you could run it on one host and actually it would work remotely because you don't need shared memory. So it does have an advantage. But. Okay, we need a U32. Okay, no field name format, so this needs to be pixel format. GBA32. Okay, and then we'll do an else. X11 does not yet support pixel format. I haven't been using the compile command as much. Okay, what's wrong? It's because, okay, you need to be U sizes now. And size.x is now height. Size.y is height, excuse me. Size.x is width. Okay, so bytes is now raw bytes, I think. Let me see what raw bytes actually does. Sig image, source image. Okay, it's returning pixels as bytes. What is pixels? Pixels is pixel storage. So actually, I probably just wanted to do this once. Yeah, that's fine, whatever. Okay. So we got rid of our custom image type and are now exclusively using the one from Zig image. Wasn't too many changes. Remove custom image type, use the one from Zig image. Okay. So we're able to display images, like some basic images, anything that Zig image supports. It'd be really cool now. Now there's like some incentive to go and add like new formats to Zig image. But I should be able to go to my other project here, my HTML CSS renderer, and Zig build image. I have an image renderer, so it will render a web page as a PPM image. So Zig out bin image renderer, give it a file, and it will create an image called render.ppm. So I can open it with Emacs, but now I should be able to use my new image viewer. And there you go. So now I can view my web page with my own image viewer. Very nice. Wait, is that right? Render.ppm? Yeah, that's right. Okay. Very, very cool. So I'll probably be using that in my workflow now. So I just want to think about what would be the next steps on this project to do. Next would be add support for Windows/Mac, add Wayland support. I mean, it will work on like Wayland-based distros that support X Wayland, which most of them will do, but it would be cool to add direct Wayland support, not just through X Wayland. And that would just be like more for, I guess, like me learning more about Wayland, I guess. It'd be fun. Adding support for Windows and Mac. Windows would probably maybe mean using GDI, and that would probably take a couple hours. Maybe I'll do that on another stream. It could be fun. I don't know how to add Mac support. I'm very unfamiliar with Mac, so if anybody wants to tackle that or has any experience with Mac, feel free to contribute, open a PR. Other than that, I think most of the other changes would be in Zig image itself would be the most benefit. But right now it's just a simple image viewer. Let's see how big it is. How big is our image viewer? And this has no dependencies, so it should just be a static binary. You should be able to take this binary, copy it to any Linux distro, and it should just work, connect to the X11 server. It is 4.1 megabytes, and if we do a zig build-d release small, how small can we get? 213 kilobytes. It's not bad. It's not bad. Does it still work in release mode? Does. There's our image viewer. Very cool. That'd be something to like figure out, is maybe scaling the image with the window size. Scale the image with the window size. Zooming. Let's add those other to-dos in there before we finish up here. Just do an amend command. Okay. Cool. So if anybody's interested, GitHub, Marler8997, image viewer. Should be public, I think. But there's the project. Feel free to contribute, take a look, use the code if you want. Yeah. But yeah, that was a fun little project. I think it's functional now for my little use case, but if we want to make it better, enhance it, make it a lot cooler, that would be fun too as well. So if anybody wants to contribute, feel free. With that, I think I'm going to end it here. Thanks for everybody who came by. Thanks for the tips and the help, as always. And I'll see you next time.